this video, we want to look at some past question walkthrough, and we'll be looking at physics topic 1 and 2 past questions. So we will begin with question number 1. Here we've got a car is traveling down a slope at 2 meters per second. The car accelerates for 4 seconds. The speed of the car increases to 12 meters per second. We are to calculate the acceleration of the car. Now, they are so good, they've given us the equation to use. So we've got here, use the equation A equals to V minus U divided by T. That is the equation we've been given, and we are to work out the acceleration. So with the equation given, what we need to do is to look for the component of the equation from the question, and then we put them in the equation and work out the acceleration. So here we have V in the equation, U in the equation, and T. So what are these? In the question, the V is 12, okay, because the speed of the car increased to 12 meters per second. So that is the final speed. The initial speed is the 2.0 meters per second here. And so with V and U known, what we got left is the T, which is 4 seconds. So what we got to do next is to just put them here. So we got V12 minus U2 divided by T, which is 4. Now, if we do 12 minus 2 divided by 4, we are going to have 2.5 meters per second squared. So that will be our acceleration for this journey. Now, question 2 is figure 7 is a velocity time graph, and figure 7 is this figure here, that graph here is the velocity time graph showing 34 seconds part of a train's journey, and they've given us the figure that is represented, assuming we are going to Manchester, and we got this velocity time graph here showing just 34 seconds of our journey from here to Manchester. So from that graph, we can work out the total distance covered within the 34 seconds and the acceleration during the 44 seconds. So that is the question and the task ahead of us. First question, calculate the acceleration of the train in 34 seconds. Calculate the acceleration of the train in 34 seconds. And I calculate the distance the train covered in the 34 seconds. So we are required to calculate the acceleration within the first 34 seconds of the journey and the distance covered. So again, in this question, we are not given the formula. So we have to find the formula. We can still use the formula here, the change in velocity over time within that time's period. What was the change in velocity? We know that acceleration is change in velocity over time, okay, the rate of change of speed over time. So we can use change in velocity, which is A equals to delta V over T, i.e. V minus U. So we come to our graph, we have to find change in velocity within the 34 seconds. Now, the time has been given to us as 34 seconds, so we got the denominator. The change in velocity will be the speed from here, the initial part of the graph, which is 14, and the top part of the graph. Now, if you can see that I've traced the graph from here to the speed section, and we can see that the speed is, the V is just one box above 25, so it will be 26. So V will be 26 minus U, which is the bottom part of the graph, that is 14. Now, so if we do 26 minus 14 divided by 34, we will get 0.35 meters per second. So that will be our acceleration within the first 34 seconds, which is represented by the velocity time graph here. So all you do is to come to your graph. If you are calculating acceleration, look for the change in speed within the time given and divide that by the time you will get the acceleration. Now the second part of the question is where you require a little bit of tact. You have to, here we are calculating the distance. Now we know that the distance under a velocity time graph is the area under the graph. So what it means is that we have to find the area under the graph. If you look at this graph here, we have this whole part of the graph representing the area covered within the 34 seconds. So what we have to do, looking at the area, is to divide the area into two so that we can get two shapes and calculate the area of the two shapes and then add them up to get the total area covered within the 34 seconds. So if I go ahead and divide the area into area A and area B, then I'll get two shapes. The first shape is a triangular shape. It's a triangle shape. The second part, which is the bottom bit, is rectangle. So we can use triangle shape to calculate the top part of the area A, and use length and breadth to calculate area B, since area B is rectangle. So let's go ahead. Area A is a triangle, so the formula for area A will be half base times height. So we have to find the base, which is the distance traveled, which is the total area of the x-axis, and that has been given to us as what? 34 seconds. So our B is 34. Now what about height? The height will be from here to the bottom part to the top part of the graph, which I've traced here to be 26. So the height will be 14 to 26, and that will be 12. So the height will be 12 because we got the bottom base is 14 and the topmost part is 26. Subtract 14 from 26, we are going to get 12. So we got our H, we got our B, so we can calculate the area A, which is half base times height because it's triangle. So if you put them in and do 34 times 12 divided by 2, we are going to get 204 meters for area A. Now let's look at area B. Area B is rectangle, so the formula for calculating rectangle is length and breadth. So we got the breadth, which is this part 34, and the length and the breadth is here, and that will be from 0 to 14, from here to here, which is 14. Okay, and so we're going to do 34 times 14, and that should give us 476 meters. That will be the area B. We got area A as 204, area B as 476 meters. Therefore, we can come here and calculate the total area under this graph, which is area A plus area B, 204 plus 476. That should give us 680 meters. That is the total distance covered by the train within the 34 seconds. Okay, so if you are calculating the distance covered under velocity time graph, what you do is to calculate the area. You can always use the formulas of area and then use that to calculate the shape, see the shape, calculate the area for it, and that will be the distance covered. Right, next question, question 3. A cyclist travels 1,200 meters in a time of 80 seconds. Calculate the average speed of the cyclist. Use the equation speed equals to distance over time. Straightforward, very easy question. They've given us the formula to use distance over time. So all that we are doing in this question is to look for, again, the parameters, put them in the equation, and calculate the speed. So here we are looking for distance. From the question, a cyclist traveled 1,200 meters. So that represents the distance. We come here, we put our distance down 1,200. Divide our distance by the time. What is the time? That distance was covered in 80 seconds. So that is our time. Put the time there. So if we do 1,200 divided by 80, we will get that speed to be what? 15 meters per second. 15 meters per second. So that represents the speed covered within the speed of the cyclist within the 80 seconds. Okay, hope this helped.